Okay, the class is live now. So guys, today we're going to talk about AWS Cloud Security, right? Super important module, okay? Super important module for the course, okay? So I want to tell you something before we start. Come ready tomorrow. We may have a test first time of the class, okay? So we at 5:30. So we may have a class like the first 20 or 25 minutes of the class. Okay?
Tomorrow, Friday.
Yes, sorry, Friday. I always get confused.
No worries.
Always. I have a class every day in the morning, so I'm still connected with the class in the morning. So
Not a problem. Thank you.
thank you. So topics: AWS Share Responsibility Model, super important for the exam. Super important for the exam. AWS Identity and Access Management, IAM. You know, an IAM is going to be with you forever. Okay. Securing a new AWS account, securing accounts, securing data on AWS, working to ensure compliance. Okay, so activities, we're gonna have some activity with AWS Shared Responsibility Model, and then we're gonna see a recorded demonstration of IAM. Lab, we have the introduction to AWS IAM. Okay, so this is gonna be our first lab today, and then the knowledge check little quiz that you guys have um, for every module. Okay. Okay. After completing this module, you're going to be able to recognize the shared responsibility model, identify the responsibility of the customer and AWS, recognize IAM users and groups and roles, and describe different types of security credentials in IAM, identify the steps to securing a new AWS account, explore IAM users and groups,
Oye, una
recognize
cosita.
how
Te voy a llamar más tarde. ¿Te interesaría pasar un curso de AWS? Para certificarte.
Hello, I'm listening to you. Okay, explore IAM users and groups, recognize how to secure AWS data, recognize AWS compliance programs. Okay, so let's talk about the first section, which is the AWS Share Responsibility Model. This is a very important chart that was taken straight from the AWS website documentation. Okay, so customers, like I said before, they are responsible for the security in the cloud, and AWS is responsible for the security of the cloud. So whatever is outside your platform, outside the console, right? Everything that you can do in the console, everything that is outside is AWS's responsibility. It's like the data center security, the security of the security services, if you understand what I'm saying. Let's say that we talk about, for example, IAM, right? The security of IAM is responsibility of AWS. Your responsibility is your account, your services, your interaction between services, your users, your groups. You are responsible for that. AWS make sure that that IAM is working properly. Okay, that's what matters here. So customer data is your responsibility. It's no one else's responsibility. AWS will never touch your data. Okay, they will never touch your data. That's your responsibility, right? You safeguard your data, you protect it, you encrypt it. That's your responsibility, right? AWS doesn't have what you have in your data. They don't care. What they care is provide you with the resources to make it secure. Okay. The platform, the application's identity and access management is your responsibility. Okay. Operating system is your responsibility. Network and firewall configuration is your responsibility, right? That's everything that is in the cloud, right? That's in the cloud. Client-side data, encryption and data integrity authentication, that's your responsibility. Server-side encryption, file system or data, that's your responsibility. Networking traffic protection, encryption, integrity, identity, that's your responsibility. You see how much responsibility you have as a customer? Okay. Now, AWS responsibility is the software, okay? The compute, storage, database, and networking to make those services operational and secure for you, okay? Then you use those services to secure your data. But AWS ensures that those services are secure outside your platform, okay? Outside your architecture, okay? It's like an umbrella, and then you are inside the umbrella. He protects everything that comes to the umbrella, okay? Everything that tries to penetrate the umbrella, they protect that. Whatever is inside the umbrella is your responsibility. I don't know if you understand what I'm saying, guys. AWS protects the umbrella, you protect what is inside the umbrella, okay? That's how it works. So, hardware and AWS global infrastructure, okay, the regions, availability zones, and locations. So you have to work on that just to make sure that you are in the correct region.
Quick question. A denial of service. Who would handle that?
Okay, you have to protect your data, right? We're going to see today a service name shield that AWS provides for that. For those attacks, DDoS. So you have to use that. If you want to protect your data, make it more secure, you can use that service. Now that service has two flavors, standard and advanced. Standard is free, advanced is not free. So, you have to see what your needs are, and then you choose the one that you think is the best for you. But if you want to have more features, then you would have to go for the advanced one. Okay, if your data is very important, then you might need to consider the advanced option. Okay. Security of the cloud. Okay, of the cloud. AWS responsibility, physical security of the data centers. That makes sense, right? They have to secure the data, that the data centers with people there. They have to have security guards. They have to have people that control the place, right? Control, need-based access. So they control the access to these places, and they have people that, they have surveillance cameras that, is just recording whatever is happening in the outside, Now we have here AWS services, compute, storage, database, networking, AWS is responsible for that, right? And the AWS global infrastructure, regions, availability zones, edge location. So AWS makes sure that this is operational and this is properly working, okay? They make sure that that's happening, okay? They make sure that the EC2 instance as a service is protected as a service. Now, when you use the EC2 instance, you have to make sure that your data is protected, okay? Remember when we saw before, customer data, you see it right there? Customer data is your responsibility, right? Now, AWS is responsible for the software and the hardware and the AWS global infrastructure. All of that is AWS's responsibility. Your data is your responsibility. The encryption, whether client side or server side, is your responsibility. Okay, AWS has to take care of their hardware and software infrastructure. Storage decommissioning. When they don't need the storage anymore, that they decommission it. Okay, host operating system, right? OS access logging, auditing. Just as you have to be compliant, right? AWS has to be compliant too, because AWS has to, respond to higher institutions that are controlling the security, that the companies are compliant with the standards. AWS has to be compliant too, Okay, AWS has network infrastructure intrusion detection. So these intrusion detection systems, they have that in place, and they have virtualization infrastructure like instance isolation. They have all that in place to make sure that everything is working right for you guys as a customer. Right now, this is your responsibility. Be careful with this preposition here. This preposition of is for AWS. This preposition in is for the customer. That's very important. Okay, so let's say that the operating system of an EC2 instance is your responsibility, right? Because remember that that an Amazon EC2 instance is not a fully managed service, and if it's not a fully managed service, it means that you have to manage the service, right? So EC2 is an unmanaged service. You have to include the operating system. You have to patch it. You have to maintain it. You have to update it. It's your responsibility. Application, the passwords, you have to, set the passwords for the users. You have to change it. That's your responsibility. That's never AWS's responsibility. When it comes to your data, they have nothing to do with your data. Okay? Be careful with that in your exam. They don't mess up with your data. They don't even know what you have. Okay? Role-based access, when you create a role, right, for a Lambda function to access an S3 bucket, that's your responsibility. You have to create that role. Otherwise, they will not interact with each other. They won't interact. Okay? Security group, you have to create the security groups like we did on Monday. We created an EC2 instance, right? We created it, and then we created the security group, right? That's what we did. We open port 22 and open port 80. That's our responsibility, right? The firewalls, okay, like the security group or the NACLs, the network access control list that we put in the subnet level, that is our responsibility, right? Including intrusion detection or prevention systems. Everything that we use to protect our data is our responsibility, okay? Network configurations, we have to configure our VPC. We have to configure the VPC logs to get a list of all the IP addresses that have been accepted and rejected in the network. We have to configure the access logs from the load balancers to get all the information, all the IP addresses that are trying to access our network. Account management, we have to create users, we have to create groups, roles, we have to set up permissions for the users, you have to create the different groups and give permissions to the group, okay? That is your responsibility, right? Like we said before, client-side data encryption, server-side encryption, network traffic protection, all of this is your responsibility. In other words, basically what AWS does is they put the platform in your hands and then you have to work with it. The platform is already protected. Now you have to use that protected platform to protect your services, all right? By using, the different services that AWS provides. So you protect your data and your information, okay? Service characteristics and security responsibility. Remember that we studied the three service models that we have in AWS: infrastructure as a service and platform as a service, right? So we have examples of services that are managed by the customer. This is an unmanaged. When you say managed by the customer, is an unmanaged service. Why unmanaged? Because AWS doesn't manage it, okay? So EC2 instances is not managed by AWS. Elastic Block Store is not managed by AWS. Okay, Amazon Virtual Private Cloud is not managed by AWS. It's your responsibility. Okay, so the customer has more flexibility over configuring networking and storage settings. This is exactly what we cover on the first day of classes. When you have infrastructure as a code or IaaS, we have more flexibility. We can manipulate things more easily. If we have platform as a service, we have less control, okay? And basically it's managed by AWS. You don't have to do anything else, right? So here the customer is has more flexibility over configuring networking and storage, right? Settings. The customer is responsible for managing some aspects of the security, and the customer configures the access controls. All right. This has to do with your data. Platform as a service. This is managed by AWS. The customer does not need to manage the underlying infrastructure. Remember Elastic Beanstalk? Did we manage any underlying infrastructure? No, we just uploaded the code, right? That sample in Node.js that AWS provides. And then we just created the environment, right? And the environment created everything for us, created the Elastic Load Balancer, the EC2 instances, the security group, the Elastic IP, all those things, and then deployed the website with the no application, right? We didn't have to do anything. We just uploaded the code, right? Anything in the underlying infrastructure. AWS handles the operating system, database batching, firewall configuration, and disaster recovery, okay? And the customer can focus on managing code or data. We manage the code, we prepare, we just code the application, and we upload it. In that case, we have Lambda. When we created Lambda on Monday, did we work with the underlying infrastructure? No, we just created the Lambda function. We selected the platform. It was Python. That was the language, Python 3.8. And then what did Lambda do? It created a function for us based on the language. The function said, just printed hello, from Lambda, something like that. And we didn't have to work on that. Now, Amazon Relational Database Service is an Amazon RDS, right? This is a managed service by AWS. We don't have to do anything. We just choose what engine we're using. Are we using Postgres? Are we using SQL Server? Are we using Aurora database? Are we using MariaDB? What are we using? Are we using Oracle? Whatever platform or whatever engine of the 6 engines that RDS supports, we choose. That is not going to be managed for us. It's going to by us. It's going to be managed by AWS. Okay, so this is something it's a managed service. And of course, I just spoke a few minutes ago. I spoke about Elastic Beanstalk. It's a managed service as well. It's a platform as a service. Okay, so here we have two other services that are platform as a service, as you can see here, AWS Lambda and Amazon RDS. Okay, so service characteristics and security responsibility continue. Okay, we have here SaaS, software as a service, right? Software as a service is centrally hosted, right? And here we have no control at all, right? We have no control at all, right? Remember Office 365, Dropbox, Google Drive, we have no control, right? We can create folders, we can upload folders, upload files, right? We can delete folders, we can, delete files, all that, but we have no control of the underlying infrastructure, no control whatsoever, right? So in that case, we have AWS Trusted Advisor, AWS Shield, and Amazon Chime. Okay, this is a meeting software that AWS uses and Amazon uses for communication with other departments and just basically having meetings, virtual meetings. Okay. Now, licensed, usually they're licensed. You have to pay for Office 365, right? And you can be pay as you go basis, right? Services are typically accessed via web browser, mobile app, or application programming interface or API. The customers do not need to manage the infrastructure that supports the service. We don't manage anything. It's unmanaged too. Okay. it's a managed by us, managed by AWS. That's what I'm trying to say. Okay. So AWS Share Responsibility model. Okay. Let's consider this deployment. Who is responsible, AWS or the customer? Okay, so we have the AWS Cloud. We have Amazon Simple Storage Service S3. We have the AWS Global Infrastructure. We have the virtual private cloud, or VPC. Inside the virtual private cloud, we have an Amazon EC2 instance and an Oracle database. Okay, who is responsible for upgrades and patches to the operating system of the EC2 instance?
Yeah.
Customer.
I'm sorry?
Customer.
The owner of the account.
The customer. Okay?
The customer, yes.
EC2 instance is an unmanaged service. It's managed by the customer, right? When I say unmanaged, it means that AWS doesn't manage it. When I say it's a managed service, it means that AWS manages it, okay? Physical security of the data center. Who is responsible for that?
AWS.
AWS, right? Virtualization infrastructure. Who is responsible for that? AWS. Good. EC2 security group settings.
The customer.
Customer. Good. Configuration of applications that run on the EC2 instance.
Customer.
The customer. Oracle upgrades or patches if the Oracle instance runs as an Amazon RD.
AWS.
AWS. Good. Oracle upgrades or patches if the Oracle runs as an EC2 instance.
Customer.
Right. Hear this, guys. You have two ways to host a database. Two ways in AWS. One is by using RDS, right? That comes with the engine already. You just have to select it, right? And the other way is having a virtual machine, an EC2 instance, and then you have to install the database. That is managed by you because you have to install the database. If it is an RDS, then AWS manages everything, right, for you. Just think about it. The second case, number 7, imagine you have a computer, right? And then you want to install SQL Server, right? The EC2 instance is your computer. And then you have to install that SQL Server software. You have to install it, right? The same thing. You have to manage that. No one is going to come from another planet and install it for you. You have to install it, unless you have a friend or someone that you know and installs it for you. But anyway, it has to be installed by the other person. So that's going to be managed by you or by another person. But no company, the cloud provider, is not going to do it for you. Okay, same thing here. S3 bucket access configuration.
Custom.
Correct. You are the one that has to create the bucket. You are the one that has to upload the buckets. You are the one, not the buckets, the files. You're the one that has to configure it and set the bucket to receive only information that is encrypted. That's server-side encryption. You're the one that can force encryption in transit. You are the one that can restrict the access to the bucket. You are the one that has policies in the bucket. You're the one that configure the access to the bucket. Okay, not AWS. Now consider this deployment. Who is responsible, AWS or the customer? We have AWS Management Console, Secure Shell, SSH, keys, right? Port 22, don't forget that. AWS Command Line Interface, ACLI, Internet Gateway, Web Server on the Amazon EC2 instance, right? And the S3 bucket with objects, and the subnet and the VPC. Okay, so we have a good architecture here, right? So who is responsible for ensuring that the AWS Management Console is not hacked?
AWS.
Customer.
AWS.
Hacked?
AWS was the one who created.
AWS.
Custom.
Okay.
Hack.
Hacked. You know, it's not just that someone.
Hack. Yeah, this is
Someone
global.
steals your
Yeah,
password, that is different. Someone steals your password, that's different,
got it.
right? AWS is not gonna be watching over you and say, "Oh, someone stole your password." No, no, no. But hacked, like a hacker tried to penetrate the system, that's AWS's. Configuring the subnet,
Customer.
the customer. You're the one that has to put the NACL in place. You're the one that has to um, associate the subnet with the route table. You're the one that has to be just put the entries in the subnet for access. You're the one that have to do that. Configuring the VPC,
The customer.
the customer. Very good. You're the one that has to put the subnets in place. You're the one that has to put all the VPC logs, just enable them to be able to capture all those IP addresses that were rejected or accepted into your VPC. Okay, protecting against network outages in AWS region. That's easy.
AWS.
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 You don't have anything to do with outages. That's AWS's thing. Okay, securing the SSH keys.
Customer.
Customer.
Remember when we created an EC2 instance at the end of the process, it asked me to proceed with the key or without a key or create a new key. Remember? I download that key, right? And I have to safeguard that key. I have to put it in a safe place. I am responsible for those keys. If I lose the key, I will have to create the keys again because there's no way I can recover those keys. Okay, so that's very important. Okay. Ensuring network isolation between AWS customers' data.
AWS.
AWS.
Okay, AWS. Good. 7, ensuring low latency network connection between the web server and the S3 bucket.
AWS.
Who?
I think customer.
Customer. Customer.
No, you don't ensure the speed.
AWS.
AWS.
Remember, you don't
It's
ensure
latency.
you provide it for the speed to be faster by using some service in AWS. You know, by using CloudFront, I'm putting the CloudFront close to your the L location close to your customers, but you cannot guarantee the speed of those of that movement. You cannot do that. You can cooperate for that to happen, but you cannot control the speed of your network connection. That's AWS. By perfecting the process, by ensuring that things are working properly, but strengthening, the resources they have, but there's nothing that I can do about it. I can put my services close to my customers, right? But I cannot guarantee that the access is going to be fast or faster or slower. That's AWS's responsibility. Who enforces multi-factor authentication?
Customer.
Customer.
No, for sure.
That's you, right? If I go here to my console, right? Go ahead, Florentina.
It's customer.
Florentina, I know your voice, whatever you are.
Hi.
Okay, let me see if I can log into my.
I have a question.
Go ahead.
For example, we have applied the patching to the web server Apache of the application deploying Beanstalk maps. AWS is insured for this or customer?
Okay. Can you repeat that again? I don't understand, Omar, what you're saying.
For example, we have to apply Apache to web server, for example, Apache.
Yes.
Of the application deployed in AWS Beanstalk services.
Yes.
AWS is in charge for this action or is the customer?
Okay, you install an Apache service and an EC2 instance, right?
No, I'm using Beanstalk services.
Mm-hmm. Okay. Remember, in Beanstalk, you don't install anything. Beanstalk, you just upload the code. That's it. right? Now,
Okay,
And maybe his
are you going to deploy, for example, .NET?
you don't need an
Have
Apache
you-
server. You don't need an Apache server with Beanstalk. Beanstalk will deploy the application for you. It will
Right.
create an EC2 instance in the background, a web server for you that has all the requirements and the software and everything that it needs to deploy your website, if it is a website. You don't have to worry about anything.
Okay, thank you.
With platform as a service, you don't have control of that. It's a platform, okay? You can do that when you have infrastructure as a code, and that is an EC2 instance. When you create the EC2 instance yourself, but you don't create anything with Elastic Beanstalk. Elastic Beanstalk will create it for you. Elastic Beanstalk, what you do is you get your code and upload it, and it is smart enough to know what it needs to deploy the application. So that we create all the services that are needed to deploy that application for you. So it will create a web server, it will create the Elastic Load Balancers, it will create the security groups, it will create the Elastic IP, it will create all the services that are needed to deploy that. Remember, you choose the platform. When you choose the platform, let me come here, Elastic Beanstalk. When you choose the platform, right? See web server here. You're gonna select the platform here, right? You choose the platform. It will deploy that depending on whatever platform you're choosing. If it is a Java application, it will prepare everything, that a Java application needs. Of course, it's gonna create an EC2 instance in the background because a server is needed to deploy that. Okay, and it will create everything that you need, right? You don't need to install anything. It's platform as a service. You don't manage the underlying infrastructure, right? If you have an EC2 instance, then you can install, you have more control, you have more flexibility because that's infrastructure as a code, not as a code, as a service, okay? Elastic Beanstalk will do it for you. Everything will do it for you. It's a managed service, right? If we go back here, let me see if I can go back here. Sorry. Here, right? The customer does not need to manage the online infrastructure. AWS handles the operating system, database patching, firewall configuration, and disaster recovery. The customer can focus on managing what? The code or the data. That's all you need, right? You write an application in Java, create the objects, create the classes, everything that you need, create the methods, all the logic behind that, and then you just upload it in Elastic Beanstalk. Forget about the rest. You don't have to worry about the rest. It will create everything as long as it is compatible. It will create everything that you need for that, right? Even though Java is not usually used for the front end, usually Java is for the back end. So probably you have a JavaScript application or something, which is the language of the front end, or React application. Basically, I guess I show you guys an application it was in Amplify. In Amplify, I loaded some React code, and then it deployed it for me. Okay. Amplify is like a one-stop thing. It would do everything for you. Okay. It would just host the website for you.
So one question. So the moment that I deploy something using Elastic Beanstalk, and if I go into the actual EC2 instance and I configure some environment variables, for example, next time I deploy via Elastic, will it maintain the state of the environment variables and things like that?
All right, I don't know any site in the EC2 instance when you can control environment variables. I don't know. I've never seen that before. Okay.
I've had to remote, for example, I created a Windows server 2019 through Elastic Beanstalk,
Mhm.
deployed a .NET application. Then I remoted into the EC2 instance because I wanted to set an environment variable
Okay.
through PowerShell so that the application could know that it's in QA, it's in development. You get me? How could I do that better?
Okay. You're trying to modify the EC2 instance, right?
That's the thing. I want to not do it that way. And I'm imagining Elastic Beanstalk might have a way for me to tell it, okay, this deployment through Beanstalk will be for QA. The other one will be for development.
Let me see here if I have an environment inside
The
here.
way that I was thinking about doing it, I don't like it, which is I have to remote into the box, into the EC2 instance that Elastic Beanstalk created.
Yeah, I know
And
what
I
you
will have to create it there, an environment variable, so that the .NET code can pick up, environment development,
Yeah.
environment production.
Yes, that makes sense. What you're saying makes sense. Let me create this environment and let me get back to you when the environment is created. And let's see the configuration of the environment, because there's a section inside this that you can add elastic load balancers, you can change elastic load balancers, you can do other stuff here. Okay. But that's inside Elastic Beanstalk. All right. So let's wait for this to finish, and then let's get back to this. Okay. In the meantime, let's continue with this. So we were. So don't see the answers, please. Okay. So so we said that AWS is that configure. Well, actually, we did everything. All right. Good. So next one. AWS and the customer share security responsibility. AWS is responsible for the security of the cloud. Customers responsible for the security in the cloud. AWS is responsible for protecting the infrastructure, including hardware, software, networking, and facilities that run AWS cloud services. For services that are categorized as infrastructure as a service, IaaS, the customer is responsible for performing necessary security configuration and management tasks. For example, guest OS updates, security patches, firewall, security group configurations. We talked about that already. IAM, our dear friend IAM. What do we use IAM for? We use it to manage access to AWS resources. A resource is an entity in an AWS account that you can work with. Okay. Example of the resources, an Amazon EC2 instance or Amazon S3 bucket. We know that we can create roles, right, for those services to interact with each other. Okay. Now, for example, with this control who can terminate Amazon EC2 instances, it can be a person or it can be a service. So we can use a Lambda function to terminate an instance or to start an instance or to stop an instance. But for that, Lambda needs to have a role that can work with EC2 instances, right? So define fine-grained access rights. Who can access the resources? We can control that. Which resources can be accessed and what can the user do with the resource and how resources can be accessed. So all of that is going to be performed with IAM. Okay. And of course, IAM is free. You don't have to pay for anything. It's free. It's absolutely free. All right. You see, here's creating the target group, security group, auto scaling the instance. It's gonna launch auto scaling group, cloud watch, alarm, load balancer, deployment completely. Okay, let's wait for that to say okay. All right, is that okay already? So we have here safe configuration. Okay. Environment, application. So the one that we created today is This is kind of messed up with the date. It says September 17th. Today is not 17. One moment. I'm losing control of my mouse again.
So one question. Can
Go
we
ahead.
use IAM as an identity provider for web application? The same way Okta or Auth0 work.
Okay, can you repeat that again? Use IAM for what?
IAM. Can we use IAM as an identity provider for web application? Let's suppose you create a React application and you want to be able to log in the user to check, to authenticate and authenticate and authorize the user. So we can use IAM for that.
We don't use IAM for that. We use it for, we can use for the Cognito. We use for mobile, Cognito.
Okay.
And then you can use Active Directory and Cognito pool, user pools for web. And also you can use federation authentication, like using third party, like Google, Facebook, Amazon, or Twitter, those guys. But IAM is not used for authentication. IAM is used for authorization.
Okay.
Okay. Even though you give a user a username and a password, things like that, IAM is not used for that. It's mostly for access, authorization, giving access, removing access, things like that. Okay.
So we resources in the cloud.
Huh? I'm sorry?
Access to resources inside of the cloud.
Yes.
Right?
Yes. Okay. So here we have, the software instances that is using that, and then the capacity, load balancer, rolling updates and deployment, security monitoring, manage update notification, things that you can do. If you edit this, then you can have some more configuration settings here in these things. That's all you can do. If you come to the EC2 instance, let me, if I can, I don't know. Okay. So if I come to the EC2 instance section, if I grab that instance, okay. Let me see the security groups. It has 480 open, right? Let me come here, and then I can edit this and then add the SSH to be able to access this EC2 instance using port 22, right? Right. So now I can do something here when I am here in the EC2 instance. I can connect to the EC2 instance if I don't want to use the keys, right? I can connect to the EC2 instance from here. And then you can install the variables, the environment variables here. I know that that's what you don't want, right? But remember, there's not much you can do when you have this, because this is a platform as a service. So you have little control here, right? If you create the EC2 instance, you can install those environment variables at runtime if you want to, by using the user data section like we did on Monday, right? Chicken instance here. You can do things like here in this section here. You can do some stuff here, right? Which is basically what you can do once you have SSH. But this is a runtime, right? Platform as a service, you're kind of limited, okay? You're kind of limited, even if it tells you here, you see, this is Elastic Beanstalk. If you create a normal instance, you won't have this name here. So this is telling you that this instance is managed by AWS Beanstalk. So it's very, very restricted. So changes made via SSH will be lost. You see, will be lost. if the instance is replaced by auto scaling. So if you use auto scaling, that's going to be a problem, which doesn't happen if you use auto scaling with your instances, right? Kind of limited here, right? There's not much you can do with Elastic Beanstalk. Try to use infrastructure as a code if you want to have more control, okay? When you use platform and software as a service, then your control is kind of limited. You know, the more you move to the right, I'm sorry, in the graph that we saw infrastructure as a code, we saw platform as a service. I'm sorry, I always say infrastructure as a code because that's AWS Cloud Formation, and I worked with AWS Cloud Formation all the time. So infrastructure as a service, and then platform as a service, and then software as a service. The more you move to the right, the more control you lose, okay? So if you want to work with your environment variables, try to do, install things and host the website with your EC2 instance. Try to create those environment variables with that, because here you are very restricted and limited, okay? Not the best place to do that. Okay? Let me delete that environment. Okay, I don't want to be charged for that. Okay. Who was the one that spoke that asked about this?
That's Ruben.
Ruben, try to get more into an AWS solution architect course. Okay.
Gotcha.
This is not the scope of this class. This is very superficial. But if you do probably not solution architect as much, but probably a DevOps course that will teach you from the developer's perspective how to do that in AWS.
Awesome.
The tons of Udemy courses online that you can. Okay, so a person or application that can authenticate with an AWS account. Okay, so you can control that. But this is, don't forget, this is who was the one that asked me about authentication? Mulet, was it you?
Yes, it was me.
Okay. Mulet, this is authentication inside your account.
Okay.
Nothing to do with the outside. Okay, that's IAM for that, right?
Perfect.
Collection of IAM users that are granted identical authorization. And let me tell you something. Every day is getting this logging with Google, Facebook, or Twitter, or Amazon is getting more popularity every day, because you are letting Google take care of the authentication, right? Even though you have to create some code, right? You have to create code in your application to be able to, make that compatible with your application. But the one that controls the authentication, the password, the cookie that comes with the password, that ID of your email is Google. So it makes things easier for the developer. And at the same time, maybe you're working with a MongoDB database, for example, or any other database they're using. You can make sure that when the user logs in for the first time, you can save that information in the database. So the next time when the user logs in again, it will be compared with the database information. And then if the user exists already, it just lets the user log in, and then it doesn't add it to the database. So that's a good way. I believe it's even more effective than having a user in a database, a user and a password box where people have to type. But there are some people that don't like to use third-party providers like Google or Facebook. They simply use the boxes to enter the username and password. So having the two options is better. It's even better. So you can let the customer choose their way. Okay. And of course, with Google Authentication, you have less control, right? You have more control when you have your own password and username and your database that's going to compare with what the user inputs. But this is getting more and more popularity. I see on the website, I see more and more companies using this third-party authentication process with Google and Facebook and other companies. It's getting popularity. And believe me, it's a headache to create it as a developer. It has a lot of steps, but it's very useful once you do it. The document that defines which resources can be accessed and the access level of access to each resource, that will be an IAM policy, okay? And this one is an IAM group, okay? And the role is a mechanism to grant a set of permissions for making AWS service requests, okay? So what is the document that is written in JSON format?
Both.
An IAM policy.
policy.
Okay, whenever you hear a format that is used or a document that is formatted using JSON, okay, that is used to grant permission or restrict permission, that's an IAM policy, or a bucket policy. So it's just a policy. Any policy that AWS has is written in JSON, JavaScript object notation, right? Don't forget that. Key value pair, key value pair. Okay. Now we have, when you define an IAM user, you select what types of access the user is permitted. Remember when we created a user, we gave the users access both managed console and programmatically. Okay, programmatically is you let the users to use the CLI. You can use the CLI. You provide the user with the access key ID and the secret key, access key, and then the person can configure, like we did the first day of class, remember? We can configure the CLI, and then by configuring the CLI, we can create whatever we want. So basically what we do in the console, it can be done in the CLI. My recommendation for you guys, become CLI people more than platform, more than console people. Console, anyone can do that. CLI, you can have merits and credits for doing that because it takes effort and it takes, dedication to learn the CLI, okay? So programmatically, you need these two guys, and then you can have access through the CLI and the SDKs, okay? Management console, you have the 12-digit account ID or aliases. You can find the ID. Let me see. We can find the ID. One moment. Let me see. Let me see if I can. Okay, one moment. Oh my God. Okay, you can find ID here. If you come here, which says support, support center. This is the account ID. It's right here. This is your account. It's a 12-digit number. Okay, that's gonna be your account ID, just in case you need it. Sometimes you will need that when you're creating policies, right? Let's say that you want your account to access a service that is in another account, you will need this number. So the other account can recognize your account. Okay, so that number is very important. All right, so you need an IAM username, an IAM password, and also if you have multi-factor authentication, then you can access that. Here, if we click on IAM real quick, guys, multi-factor authentication, you can activate this and manage the MFA here, and then we can do here and manage this guy here, the device. And then you can, in this case, I already have that, right? So you will have here something like add a device or something. And then once you do that, it's gonna provide you with a QR code. And then you can take a picture of that and it will require that you download the authenticator. And then it's gonna ask you for two rounds of digits. It's 6 digits every time. It's gonna ask you for the first time that it puts the digits, And then because the digits expire probably every 10 seconds, and then they will have new digits, and then the second round is going to ask you to enter those again. And then your account's going to be synced with that device. Okay, and that's how it's going to work for you, the same way that it works for me. Every time that I have to log in, I have to enter the code in the authenticator. Okay, good. So MFA provides increased security. It's a second layer. It's an extra layer of security. Very important. You can force all your users to create multi-factor authentication. Okay, if you are the root account and you create IAM users, you can ask them, or you can force them to add multi-factor authentication to make their account secure, and in turn, you're making your account secure. Because let's say that you give a user administrator privileges, that user can do whatever he wants. So if someone accesses his account, then you're going to have a problem. Okay. In addition to username and password, MFA requires a unique authentication code to access AWS services. There's several authenticators. My favorite one is Google Authenticator, because it's very seamless. It's super easy to work with. There are more, but I like that one. So you can have your preference as well if you want to. Okay. So I already show you guys how to find the authenticator part, right? It's right here in this section here, which says in the dashboard. You click on dashboard. Okay, I don't know why I lose control of my mouse. I don't know what's going on with the console. Okay. All right, it's right here. So we click here on dashboard, and then we're gonna have all those guys here. So in my case, I activate this in my root account, right? This is my root account, right? I just create individual users, right? I created them long time ago. I even created one, the first day of class, to show you guys how you create that. I created groups and then assign users to the group. Okay, Dunieski is a user that is assigned to the administrators group. Okay, I still haven't deleted the root access keys, which is highly recommended by AWS. AWS recommends that you disable or delete your access keys for your root account. Why? Because it's super dangerous. It's super dangerous. What AWS recommends is that you create IAM users and then use the keys of the IAM users. Okay? Not the root keys. Guys, you don't need the root keys. The root keys is only to work from the CLI, right? You don't need the root keys to access your account. For that, you have your password and your username and multi-factor authentication. You don't need them to access your account. Delete them or disable them. If you need them again, if you need that again, let me come to the user here. I have Dunieski here. If I need them again, I can come here to security credentials, right? And have the access keys for this guy. So this one here, generate credentials. So I can have here this username and password again, another one if I want to. And here, I can make this inactive, right? So I can make this inactive, right? Come on. Right. Let me delete them. This is what AWS recommends, right? Delete this guy and then create the new ones here. Okay. Just in case someone sees your keys and the person has a hold of those keys, you're going to have problems. So if you know that, rapidly, what you have to do is disable or inactivate those keys, just delete them and create new ones. Then the person would not have access to those. Okay, now I have to reconfigure my CLI because my CLI has the old ones, right? Okay, so be careful because once you create these access keys, this guy here, you have access to it once. Okay, if you don't copy that or download this CSV file, then you will lose that guy. You don't see it anymore. You see the access key, but the secret key, you don't see it anymore. Okay, so be careful when you create that. Just save them in a safe place, right? And don't lose them. Otherwise, you will have to create that. And believe me, if you have done a lot of work using those keys and you lose them, you will have to probably repeat the process again, or just picked up where you left, or I don't know. Just keep them safe. That's very important. For the root account, disable them or make them inactive or delete them. You don't need them. Okay. Good. So we continue. Authorization, what actions are permitted? Okay. That's using IAM. After the user application is connected to the AWS account, what are they allowed to do? Right? You can have a user that has full access or read only, right? So let's say that this user Dunieski, right? Right now Dunieski has administrator billing. I'm gonna delete that. Okay. But oh, I deleted Dunieski from the group. Okay. Not a problem. I add it again. Okay, good. So billing, right? I have administrator access here, right? But let's say Carlos is an administrator as well. Okay, I'm gonna remove Carlos from the administrators, right? And now Carlos is going to have probably let me see, create a group for Carlos, and then we're gonna put read only something. So we're gonna allow Carlos to have, let's see, S3 XC's read only access only. So we're gonna create that group here, and that group is gonna be named, let's say S3 read only access. Okay, just the name, right? Now I create the group, and then Carlos has been automatically added to that group. And then Carlos is in the read-only access. Now Carlos or whoever is inside this group can only read S3 buckets. When I say read, it's view, right? View. They cannot modify anything, right? They cannot do anything except read. That's it. So I can control that with IAM, right? So it's good practice to create users. To create groups, give the group the permissions, and then put the users inside, right? When the user leaves or the user is done with, finished with the project or something, or a contract, you just remove the user from the group, and that's it. Done. Okay. Assign permissions by creating an IAM policy. Permissions determine which resources and operations are allowed, or permissions are implicitly denied by default. Okay, it means that nobody went there and denied the permission. It's by default. It comes that way. It comes that way, right? Now, you can give permission to someone. If the permission is explicitly denied, it is never allowed. So it means that if someone came in and denied permission for someone, it is not allowed to change that. That is policy of the company. That was the decision of the administrator. It is not to be changed. Okay. Now, when it's denied by default, you can make some changes, and then you can give permission to that person. Okay. For some reason, someone was not allowed. Okay. That's important. Always follow the principle of the least privileges. What is that? You start from nothing, and as the job requires it, as the need arises, then you give permissions to people. Okay? So keep this expression in mind. Principle of least privilege. Okay? That's best practices in AWS. As it says here, AWS is global. Okay? IAM is global. IAM, the settings apply across AWS regions. Okay? So be careful with that. IAM is global. Policies is a document that defines permissions. We know that already. Two types of policies, identity-based and resource-based. Okay? Identity-based can be a group, a user, or a role. And resource-based, it's a resource, right? So identity-based policies, you attach a policy to any IAM entity, right? You come here, right? And then you come to policies here, right? Or create a user, right? Right? Or maybe create a policy. You create a policy here, and then you choose a service here, okay? Let's say that you want to create one for Lambda, right? So that's gonna be, okay, Lambda, somewhere in the
So
L.
type Lambda. Okay, there.
Yeah, but I lose control of the mouse. I don't know why. I don't know what's going on with this. I don't think it's my mouse, because here I have control of the mouse. But here I have control now. Okay, so I can do all Lambda functions, right? And then I can have MFA require or source IP. So I review the policy. Okay, close. Okay, what for more? Okay, specify what resource here. Okay. I put all resources here, just for now. Right. So I have an access level Lambda function. Okay. I give it a name. Okay. Lambda function. Okay. And then
Misspell it when you're creating. Didn't put the D.
I spelled it right.
Yeah, so it's Lamba.
What did I put?
It's
Lamba.
Lamba.
Like that?
Lamba.
BA.
Lamba. Oh my God. Okay, so I can have this guy here, and then policy usage, right? Version advisor. Okay. Now, this is a policy that has all the Lambda functions, right? Now I can create a role, and then the role is gonna be using probably EC2, let's say, right? And then right now, I'm gonna put here Lambda function, right? And now I continue, and I call it EC2 to Lambda, right? Create a role, and now this role this role, we have access to Lambda, right? Lambda function, and it has all the actions here. So I can apply this role to an EC2 instance, right? And the EC2 instance, we have access to Lambda. So that's how services interact with each other. Now I can add an inline policy right here, inline policy. This is an inline policy is a policy that applies to only one service, okay? So I can put here shows the service. I can put here EC2, right? Now, run, okay, run, okay. We're gonna inline policy, and we're gonna put here Lambda. You know, that doesn't make, what I'm doing doesn't make sense, guys. It's just for you to have an idea. Because if I have access, full access to Lambda, why would I add an inline policy? You see, this is for just when we have a service that is not full access. You know, you don't have full access to it. Just a small, because I already did this, right? I'm just adding probably permission, write permission. Okay, and here see all the resources, and then here, if I have any condition, I don't have any condition. So here, maybe Lambda more access, just an example, okay? And here, if I just hit this, I have two policies attached to this role, okay? This one here has full access to Lambda, which makes this one useless. But I just wanted to, you know, show you how you can add an inline policy that only applies to this particular service, right? To the service that uses this particular policy, right? So we're creating a policy, right? And that policy can be applied to a role, all right? Sometimes AWS creates it for you. Sometimes you have the options to say, create a role for me. Okay, like when you create a Lambda function, you can say, just create a basic role for me. Okay, and then AWS will create a role that Lambda can use, right? But you can also do that, right? So this is a managed policy that applies to every single service, and this one is an inline one that applies only to this service. Okay. To this particular role, because it's inline, it's right here, inline. Okay, there's a bunch of policies that are already created for me. Those are managed policies, and the ones that I create, I can also create policies if I want to. I can edit the policy, and then, you know, do this, right? In the case of an S3 bucket, there's something called a policy generator, okay? You can generate a policy, right, in an S3 bucket. A bucket policy is a different policy. This is for buckets only, okay? But you can have a policy here. If you come to permissions, you create a bucket policy here, right? Then you can type whatever you want here, right? Okay, whatever you want here, but it has to be, of course, it has to be something that makes sense. So if you have no idea how to create a policy, you can click on policy generator, okay? And then you're gonna say, this is a bucket, a three bucket, or you can have other buckets here. IAM policy, you can even create an IAM policy here, okay? But let's say you wanna create an S3 bucket. Now it's gonna be allowed. The principal is gonna be for every principal, right? The principal is the one performing the action. I'm gonna select the action here. So this policy is gonna be applied to any principal that's trying to put. Put means to add an object. Okay, add an object is to upload a file, for example. Okay, the RN is gonna be this guy here. Okay, that's the Amazon resource name. Okay, this is where the policy is gonna be applied to. Okay, so I just put here, and when we're going to add a condition, right? the condition we're gonna say, for example, that string equals, for example, this one. And then we're going to make sure that in the header of the request, we're coming, we're bringing, okay, one moment. Or probably the source IP. Let's say source IP, for example, is 192.168.1.304. Okay. See, the string equals the IP address equals. So if the IP address equals that, then you are allowed. Okay. So everybody that comes in to this bucket, right, and adds an object, try to add an object. If it is not this IP, then you're going to deny it. Well, actually allow. Okay. If it is not the same as this, then deny it. Okay. So we do add statement, right? And now it's going to generate a policy for me. So this is the policy. As you can see, it's a JSON file, right? Key value, key value, key value, key value, key value, key value. Okay. Did I add the condition?
I don't see it.
I don't think I added the condition. Okay. I didn't add the condition. Okay, so let me delete that again, real quick. Let me put it again. And then let me say put object right here. And then every principal, right? And then allow, and then add a condition. I had to click this and I didn't click on this. Okay, so IP address equals string equals so source IP. So let's say 168.192.3 and 4, and then add condition, right? And then add statement. There you go. Now it has a condition right there. All right. So I can use this guy, right, and put it here in this bucket. Okay. And now that I'm here, I can save, and I have a problem. Action that is not okay, because I mean, this is the pocket, right? I have to put this guy to be able to apply to everything inside the bucket. All right. So now if I do save, it's saved. Perfect. Now I have a policy that only this IP address can access my bucket and put an object. Okay. All right. So this is how you generate a policy. Okay. If you are not, skillful or skilled with JSON, because this is a little confusing. If you forget any curly braces or any comma here or something, it's going to give you an error. Okay. I'm going to delete this bucket, this policy, because I don't need that. Okay. So this is a policy. Okay, guys. So guys, do you have any questions? No? Yes? Maybe? Perhaps?
Or here.
Oh,
You learning something?
Yes.
Yes.
Good. Let's have a 15 minutes break because it's 6:50. Actually, it's not 15, it's 10. Let's meet back here at 7. Okay?
One quick question, Professor.
Right.
We have access to Cloud Guru. How long is gonna last that access?
It's gonna last for as long as the class is open.
Okay, thank you.
So guys, I wouldn't recommend it, using it at the end of the class. I recommend using it for now, because you don't know after the class is finished how long it's gonna be available.
Okay,
And
you're right.
If you guys are continuing, if you guys are continuing to the next class, probably you still have access to that. Okay.
How do we get access to the Cloud Guru?
You should have gotten an email. You should have gotten an email from Miami-Dade College.
Yeah. What if you didn't get the email? Is there a way they can resend that out?
Send me an email. Send me an email or send me a Slack message, and I will forward it to the person that sends it to you guys. Okay.
Cool.
Thank you. I'll see you in 10 minutes. It's see you 7:01. Guys, I'm back. I'm back here. Can you hear me?
Yes. Yes.
Yes.
Okay, thank you. Thank you. Guys, I have created this channel, a Cloud Guru channel, so that you can put here your address if you haven't received that email. Because if you send me emails separately in a private message, I'm gonna go crazy. I have so much in my head that that's gonna be difficult for me. So put your name here, right? Put your name here, and then just I will go over, your message here and send it to the person in charge. All right, that's much better. I am.
Dunieski, if we already have, I got it. I had access. I have access.
You don't have to put your email here. This is for the people that haven't.
That haven't. Okay.
Okay. I wonder, guys, why you don't have this. Do you check your junk mail? Because you guys are from the beginning of the course. So check your junk mail, right? Check your spam folder. If the email is there, please come back and delete the message here. Just click on these 3 dots and delete the message. So I don't have to tell the person if you got the email when you actually got it. Okay? So make sure, check every single folder, spam folders, junk email, things like that, and make sure that you don't have it. If I see that you don't delete the message, then I assume that you did not get it. Okay?
Okay.
Thank you. So we continue. Okay, so we have sign permission by creating an IAM policy, permission, okay. Attach a policy to any IAM entity, user group, or role. Policies specify actions that may be performed, actions that may not be performed. A single policy can be attached to multiple entities. A single entity can have multiple policies attached to it, okay? So we can get a policy and attach it to 20 users. And we can have one user that has 20 policies, okay? That's possible. Resource-based policies is attached to a resource, such as an S3 bucket, okay? So you can attach an IAM policy to an S3 bucket, right? This is how a policy looks like, okay? The action to be performed is allow. Okay, the effect is allow. The action is DynamoDB, whatever is inside DynamoDB, and whatever is inside the S3 bucket. Okay, the resource is going to be a DynamoDB. You see the region, the account number with the hyphens, and the table name. Okay, that is the ARN format of a DynamoDB. Okay, that's the way it is. In the case of the bucket, you have that there, right? Also has the region, also has the number. For example, this one has it, has this dot, right? And then the name of the bucket, right? So that's the way it is for that. So for the DynamoDB is the region, and for the bucket is the dot, bucket. All right, that's very important. This here, right? The policy that we created before, CSD have a copy here. Okay, so I can have like this here. Okay, I can have this here, right? And then I can have this here, right? And I can put another guy here, right? I can put this guy here. And just put this guy right here, right? Why do I put this? Because this is an array of resources, okay? So I put the array separated by this guy, And then if I hit save, I have invalid JSON. Okay. I don't think this goes here. That's the bad thing about this guy here. Sorry, I'm losing control of this mouse. I don't know why this is happening. And it's happening only with the AWS console. I have no idea why this is happening. And I just get back the control when I get to the PowerPoint. Okay. Containing valid, okay. I'm trying to force this, guys. I'm trying to force this. So I'm gonna remove this guy. I can simply delete everything. That's it. All right. So that's what I don't like about JSON. That if you make a mistake in these square brackets, I can fix it, but I don't have time for that now. So I prefer YAML, but YAML doesn't exist here in this type of policies. AWS doesn't accept YAML. It's JSON what they accept. Resource-based policies, identity-based policies are attached to a user, group, or role. Resource-based policies are attached to a resource, not to a group, or role. Okay, that's attached to a resource. Something that we already spoke about. What are the characteristics of a resource-based policies? Specifies who has access to the resource and what actions they can perform on it. The policy are in line only, not managed. Exactly what I showed you before. Okay. In the IAM console, I'll show you an inline policy which is not managed, and I show you the other one that is the managed policies. Resource-based policies are supported only by some AWS services, okay. Only some of them. So you have the AWS account here. IAM user Mary Major attached. It has identity-based policies because, you know, Mary is an IAM user, is an identity. And then we have an S3 bucket here that has some photos inside. You define an inline policy of the bucket on the bucket, and then that's a resource-based policy because it's a resource. An entity, it can be a group, a role, or a user. Okay. So this policy grants list, read objects to a photo bucket. And this policy grants user, Mary Major, list. Okay, of course, this is kind of, you know, crossed here, right? Because this is supposed to be here, right? Mary Major is here, not here. Okay, so it's something that has to be fixed here. How IAM determines permissions. If the permission explicitly denied, yes, deny. If the permission explicitly denied, no, then is the permission explicitly allowed? No, deny. Yes, allow. So that's how it is. Remember, we said that whatever is explicitly denied cannot be allowed. Okay, that's why it says here, if it is explicitly denied, so someone came and denied it, right? Then is yes, is denied. There's nothing you can do. No, do not change, right? If it is no, then it's going to ask you, Is the person explicitly allowed? Yes, then allow. It is not, then deny. And that will be explicitly denied. By default, that's what happens. It is the person is not, or the entity is not explicitly allowed. So when no one came and allowed the resource or the identity or the entity, I'm sorry. So that's why it's denied. But if the person came and explicitly allow that, then it allows. Do you understand this, guys? You understand it? Okay. When it says explicitly denied or explicitly allowed, it means that someone came and changed the permission. Okay. If it is explicitly denied, it's denied. Right? It's denied. It's not allowed ever. If it is not explicitly denied, then the question that I am asked is the permission explicitly allowed? If it is, then it's allowed. If it is not, then it becomes an implicitly denied. That's how I am determines permissions. Okay. So when you have some time, come back to this and just take a look at that. Okay. An IAM group is a collection of IAM users. A group is used to grant the same permission to multiple users, right? Permission is granted by attaching an IAM policy or policies to a group. A user can belong to multiple groups. There is no default group. Groups cannot be nested. It means that you cannot have a group inside a group. That doesn't happen. Okay. It doesn't exist. Okay. Now we have the IAM group admins. We have inside Carlos Salazar, Marcia Oliveira. Whatever permissions these admins have, Carlos is going to have, Marcia is going to have. Okay. So all the permissions that the group has will affect all the users inside the group. Okay. That's why it's best practice to create a group, give permissions to a group, and add users inside. That's it. You don't have to change the user permission because the user will be affected by the permission that the group has. All right. Same thing here, developers and testers. You have Lee 1, Mary Major, and then Richard Rowe. We have Sam Wei, John Styles, and then we have Lee 1, which is a tester, but also a developer. So they are in this, he's in the same group, okay? So you can be separate groups at the same time. An IAM role is an IAM identity with specific permissions, similar to an IAM user, attach permission policies to it. Different from an IAM user in that it's not uniquely associated with one person. A role is for services, right? Intended to be assumable by a person, application, or service. Let's say that, you know, a person comes to your company, right? And the person needs to audit your company. So you can create a role, because don't forget that I am user is permanent, but a role is temporary. So there's another difference between a role and an I am user. An I am user is permanent until you delete it, but an I am role is temporary. Okay, so the person will receive a role as an auditor, right? And when the person goes, you just delete the role or just detach the role from that person. Something very important: if a person is coming season, it's a season worker, someone coming for just a short time, it's better to create a role than create a user, because the user is permanent. It's for permanent actions. A role is temporary. So that's best practice. Create a role for that person that's going to be working for only a week or 2 weeks for the company. So a role will be assigned to that person, and that's it. So it can be assumable by a person, an application, or the service. See, an IAM user is by a person. Okay. Examples of how IAM roles are used to delegate access. Use an IAM user in the same AWS account as the role. Used by AWS service, such as Amazon EC2 in the same account as the role. and used by an IAM user in a different AWS account than the role. So that's the way that IAM roles work to delegate access. You can have a cross account role. Okay, so other account can have access to another account. Okay, so that's how roles work. Okay, it's not difficult to understand. It's just you know um, having a clear idea how it works. That can be used for a person or for a service or application. Okay, but it's temporary. Don't forget that. Roles provide temporary security credentials. Scenario here, an application that runs on an EC2 instance needs access to an S3 bucket. The solution, what is the solution here? Define an IAM policy that grants access to S3 bucket, attach the policy to a role, allow the EC2 instance to assume the role. So you're creating a role that allows the EC2 instance to access the S3 bucket. The role is going to be assumed by the EC2 instance, right? Because the EC2 instance is going to be attached to that role. Now, here we have an AWS Cloud, the AWS Cloud, Amazon EC2 instance, right? The application has permissions to access to the S3 bucket because of this role that the EC2 is assuming. And then we have here the IAM policy that grants access to the photos bucket. The IAM role has that policy attached. This role is going to be attached to the EC2 instance, and that EC2 instance is going to be assuming that role, and then the application can access the photos from the S3 bucket. Okay, that's the process. You create the policy first. You have the policy in place, right? Then you create the role attached to the policy. Then you create the EC2 instance attached to the role, and then EC2 instance can access the bucket. That's how it's done. IAM policies are constructed with JSON, right? And define permissions. Don't forget that. IAM policy, JSON. IAM policies can be attached to any IAM entity. Entities are IAM users, groups, or roles, right? An IAM user provides a way for a person, application, or service to authenticate to AWS. An IAM group is a simple way to attach the same policies to multiple users. An IAM role can have permissions policies attached to it and can be used to delegate temporary access to users or application. Just just summarizing what we saw already. Setup demo. Okay. I think, guys, that I've done this before already. I have created users, I have created groups, I have created roles, I have created policies. I've shown you how to set up MFA. I have shown you how to recreate the access key and the secret access key. I have shown you how to configure the CLI. I have shown you how to generate a policy. I think that we have done a lot, like just a basic demo of the IAM user groups and roles. Okay. Securing a new AWS account. Here we have an AWS account, root users, access versus IAM, right? The root user privileges cannot be controlled. Okay. Once you create the account, there's nothing you can do about the control of that root. It has default controls, and you cannot change them. It is the master account. Okay? It's the master user. There's nothing you can do to change that. Okay? It has all the access in the world. Is the root user. It can do anything in their account. Okay. Now, when you create an IAM user, then limitations start, because the root user controls that account or that user access. It can integrate with other users, services. It has identity federation. Okay. It has secure access for applications. It has granular permissions. So you can specify and you can delegate specific permissions for that person. Okay. Now, federation identity in AWS. Okay. You see, Amazon Cornado, right? Amazon Cornado identity pools, federated identities, enable you to create unique identities for your users and federate them with identity providers. You know, identity providers, Google, Facebook, you know, those guys. With an identity pool, you can obtain temporary limited privilege AWS credentials to access other AWS services, right? So in here, you can just have the Cornado service here, and it's a service for management and identity pools, user pools, or user directories that provide sign up and sign in option for your app users. Identity pool provide AWS credentials to grant your users access to other AWS services. So you can create a user pool, right? Right here. I have some here, and then you can have some configuration here, right? And user pool here, you can create a user pool, and then you start working with this and can give it a name, and then you can review the defaults, right? And for example, you start creating here emails, alias, user attributes. You can choose one here, allow signing with verified email. Just making sure that the person has an email is required. You can just require birth date, or maybe a phone number, or a picture, or preferred username, things like that. Okay, that's gonna be very useful when working with Cornado in the mobile apps and using federation identities. So this is very important when you are just studying for your developer or DevOps certification. Okay, right? And this has to do a lot with when you have a hybrid infrastructure. This is another service that's going to be very related to this, is the directory service, which is named as you know um, Active Directory. Okay, this is very commonly used as well when you have hybrid infrastructure. You can let the people from the office in on premises to access the services using this directory types. All right. Not for this certification, but for others, just in case you want to further your certification career path in AWS. Do not use the AWS account root except when necessary. That's what I told you before. Access to the account root user requires logging in with the email address and password that you use to create the account. If you lose this, guys, you're gonna be in serious trouble, okay, with your account. In our case right now, we have a free tier account. We don't have anything important, right? But if you have a company, that's gonna cost you a lot. So be careful. Example actions that can only be done with the root account: update the account root user password, okay? Change the AWS support plan, just in case you want to go from basic to developer, or from developer to business, and then from business to enterprise, things like that. Restore the IAM permissions, okay, just in case I have Dunieski as a user, just in case I want to change Dunieski's permissions, then I would have to use the root account for that, okay? Change account settings, for example, contact information, allow regions, okay? You can control the allow regions in your account. These are the instances, or some of the examples when you can use the root account. Other than this, right, and any other important information or actions, use a user, IAM user account, okay? Or use an IAM user. It's the same account, but use an IAM user. Stop using the account root user as soon as possible. The account root user has unrestricted access to all of your resources. To stop using the account root user, while you're logged in the account root user, this is something you already know, guys. Create an IAM user for yourself, save the access keys if needed, create an IAM rule, give it full administrator permissions, and add the IAM user to the group. Disable and remove your account root user access keys if they exist. Enable a password policy for users. Sign in with your new IAM user credentials. Store your account root user credentials in a secure place. You can use something called store parameter. Okay. My God. Okay. There's something called systems manager. Okay. Systems manager. So systems manager has something called parameter store right here. Parameter store is the second most secure place to store variables. Okay, so you can put here variable. Let's say, for example, this is my password, right? And then you can encrypt it, right? Secure string. You can encrypt it, and then use the value here, the value, and save it, right? That's the one of the ways that's a place to save the credentials of your database. Okay, very important. Do not save your credentials in an EC2 instance. Okay, this is the preferred place to store credentials. Is called the AWS Secrets Manager. Super important. Okay, it's 40 cents per secret per month. Okay, and 5 cents per 10,000 API calls. Okay, so you can store it here for RDS, for DB document, for Redshift cluster, for all the database, all the types of secrets. Okay, just put here, let's say username, and then here you can do a plain text, or you can do it here, and they can say here, not username, password. Okay, or maybe I am, say, user password, and then say here pass, for example, right? And then I click next, and then I give it a name. I say my I am user password secret, right? And then I can put the description here, and then I click in next. And then I can enable rotation just in case I want to every 30 days. It's going to ask me for that. For now, I'm going to leave it that way. Then next, this is how it looks in Java, right? To be able to do an API call, right? From Java. So view a code sample illustrates how to retrieve the secret in your application, okay? JavaScript, right? C#, right? Python 3, Ruby, Go, right? Good, store. There you go, store now. This is super, super, super duper secure, okay? Now, right now, I'm going to delete this because it's 40 cents per month, which I don't want to pay, okay? So enter a waiting period, 30 days. Why? I don't want to wait. So it must be between 7 and okay. You see? Okay, it has to be between 7 and 30. Okay, not a problem. This secret was deleted on 9/3. Okay, that's okay. So I can cancel. I still have 7 days to just to regret this action. Okay, and just cancel the deletion. After 7 days, boom, disappears. Okay, so that's the secrets manager. Very super safe. I mean, like, you know, hidden and secure. Okay, so that's what it is. Okay, enable multi-factor authentication, super useful. It's an extra layer of security, right? Super important. Create an IAM while logged in as the account root user. I'm just doing the same thing. All right, so require MFA for your account root user and for all IAM users. Guys, if I want to come here, okay, one moment. So if I come here and I just hit IAM, right? There's a policy here. Let me see, password policy. And then I can, force this, set password. I can say the password, enforce minimum password length, 6 characters. I want the password to require at least one lowercase, right? I want the password to require at least a non-alphanumeric character, like an @ symbol, hashtag or something. I want to allow the user to change the password. No. I want to prevent password use. Yes. I want to go back 10 passwords. Okay. I want the password to have at least one uppercase. Right. And then I can save that. Okay. So that will make sure that every user, when they create a password, because when I create a user, right, let me cancel that. When I create a user, right, I can have the user create their own password at the next sign in. Okay, let me say Juanito. Okay, Juanito. So I'm gonna give Juanito access programmatically and the console. So it's gonna auto generate a password, and then the next time when Juanito logs in, right, it will have to create a password. Now I can, before this, I can create that policy password or that password policy, and then Juanito will have to, comply with that policy when he creates the password. Okay. So that's how you create that. Option for retrieving the MFA token, virtual MFA compliant application, Google Authenticator, Authy Authenticator, Windows Phone app. Okay, you can use that one too. UTF security security devices, for example, YubiKey, hardware MFA options, key fog, or display card offered by Gemalto. Okay, so Gemalto is right here, multi-factor authentication, and then you guys can explore this later when you have some time. All right, my favorite, Google Authenticator. It's a seamless experience. So AWS Cloud Trail, this is a guy that helps secure your account. It's a very tough guy. He's gonna track every single activity in your account. Everything, guys, everything. You change the password, Cloud Trails picks it up. You change a letter, a username, Cloud Trail picks it up. It tells you the time, who did it, and everything, and what resource was used. Everything. Cloud Trail is the guy.
What's the difference between CloudTrail and CloudWatch?
CloudWatch is a monitoring service for services. It's to know the health of your service, how healthy it is, the CPU usage, the RAM memory use, everything. CloudTrail records every single API call, every single activity of your account. They're similar, but they're not the same. They're both there to help your account to function better. But CloudWatch is for automation. It helps with automation. You can schedule activities and tasks with CloudWatch, and CloudWatch will be telling you how much was used from your EC2 instance, how much CPU is being used right now, how much RAM is being used right now. What it's gonna log everything related to your service, right? It's gonna log everything. CloudTrail will work for the entire account to record every event that takes place in your account. Someone changes the password, someone logs in, someone logs out, everything is gonna record that. Okay, that's the big difference. So CloudTrail is for auditing, governance, and compliance, and CloudWatch is for monitoring. Okay, and automation. Two different things, but still they're related. Did that answer your question?
Yes, definitely.
Okay, thank you. So basic AWS Cloud Trail again is enabled by default and it's free. So you have a basic and advanced one. Okay. It's by default. Okay. But if you want to have more, then you have to go for the other one. Okay. And then you can create a trail. Okay. Okay, so you have here Cloud Trail. Cloud Trail. It's for every single API usage. So you create a trail here. Okay, you can create a trail. You give it a name, enable for all accounts in my organization. You know, you have member accounts in your organization, remember guys? You can create a new S3 bucket to log all the trails, okay? To log every single API call. Because the service that is used for logging persistence of the logs is S3 bucket. That's the service. If you want to keep those logs safe, you will create a bucket and you will save those logs there. Okay. Once you create that trail, you're gonna be charged for that. You know, you're gonna be charged for trails. This is for more advanced training. Okay. For the default one, you don't have to create a trail. Okay. But S3 bucket, for example, you come here, X3 bucket, and then you see when you create a bucket, right? Then you can come here to management and properties. And then in properties, it has default encryption, right? So you can just, you know, make this encryption with advanced encryption standard 256, and then you can save it. Now, from now on, everything that comes in into your bucket is going to be encrypted. Everything. If I upload a file now, let's see, this is the bucket, right? It's this one, right? Let me upload just a file. Whatever file I want to upload, this just says here, all the services, this is, for example. And then I upload that, right? Let me upload it. Right now, if I take a look at that file, it's going to tell me that it is encrypted. Okay? So that's called server-side encryption. Okay? Whenever you enable server-side encryption in an S3 bucket, everything that comes after that will be encrypted. You don't have to encrypt it in transit or anything. As soon as it falls there, it's going to be encrypted. Okay? Of course, you can force encryption in transit and client side. Okay? Now you can also, in properties, you can also enable, it's already enabled, versioning. Versioning is good for hacking. If someone wants to hack your account, whenever you upload something, it's going to create a version for you. So when the hacker comes in, he gets the original, but you still have the version. In case they take the original and you don't have versioning, you lost it. Okay? So it's a good thing to have versioning. Okay, it's enabled right here. And then whenever you upload something, I just uploaded a file, right? Let me take a look at the version of that file. So I'm gonna click here, come here, let me select it here. If I take a look at show, it shows me a version of that file. Okay, this is a version. Okay. So I have two files here. I have the original and I have the version here. Every time that I change the file and upload it, it's going to create a new version for me. This is like a mini GitHub, a mini GitHub. It's going to give you a new version of every single commit. So this is a good thing. Versioning is good. It's good for, you know, maintaining your files in your bucket. So there's a bunch of things here that you can do here with, you know, with the bucket, right? So many things that you can do. You can even enable cores, you know, cross-origin replication thing here. And some of the things that you can do. This is awesome. AWS is
How advisable is it to actually host applications off of S3?
S3. You can host static websites. Okay, static websites.
Or
Is
specific applications, for example, like React.
I don't think. Well, you can because I did. I uploaded one website on that. It is good because your information can be encrypted, right? And also you can have policies that restrict the access, and it's super safe because S3 is super safe and it's very stable, and it has replication as well, so it's super highly available. I think it's a good thing. And also another factor is cost. It's super ridiculously cheap. We're talking about probably 50 cents a month. It's super cheap. Okay. You know, you guys know that hosting a website is a lot of money. You know, if you just try GhostGator or tried GoDaddy, it's gonna cost you probably over $100 a year. Probably more or less around $100 a year. With AWS, you will pay probably 50 cents a month too. So that's how much is that? $6 a month, a year, more or less. So I believe that it's, it depends on how much data you have. Remember, you're gonna be charged by a gigabyte. Okay. You are charged for compute, storage, and outbound transfer, right? If you're storing a lot, right, the more you store, the more you will pay, right? So if your website has a lot of code and it's heavy, has a lot of pictures, right, and things like that, if you're storing, for example, a retail store, it has a lot of pictures, images for your products, things like that. That's gonna cost you more money, right? But I would recommend it. If it is a static website, I would recommend it, right? Because that's what you do with S3 bucket. Let me show you here where you can enable that. Okay, one moment. Okay. There's something wrong with the console. Guys, is it happening to you? Are you trying to access the console while I'm doing this? Okay. Okay, let me show you here. Here in properties, there's static website hosting. You see? You can host this from a bucket. Just use this bucket to host a website. So you can put the entry file in this document, and then you can do this and then enable hosting. As soon as you upload that, it's going to look for that file, index.html. Okay. You may have to do some work around here to be able to make it work. I had to create another bucket and then redirect from one to the other to make it work. But you can Google that, and that's going to be a piece of cake. Okay. But this is what you enable to host a static website. Okay. And it doesn't require server-side technology. Okay. It will be done by AWS, all of that. I firmly recommend it. Okay. Best practices to secure an AWS account: secure logins with multi-factor authentication, delete account root user access keys, create individual IAM users and grant permissions according to the principle of least privilege, use groups to assign permissions to IAM users, configure a strong password policy, delegate using roles instead of sharing credentials, monitor account activity by using AWS Cloud Trail. Guys, remember this, right? Because that's going to be super important for your exam. So this very well describes or summarizes what we've seen in this section. Okay, this is going to be in your exam one way or another. This, information here. So the lab that we're going to start today, okay, introduction to IAM users, okay. So we're going to explore the users and groups, add users to groups, signing and test users, right? The final product is going to be users, user 1, 2, and 3, admin, EC2, and groups are going to be EC2 admin, EC2 support, S3 support. Inside that group, EC2 support, we're going to have user 2, right? And then inside the EC2 admin, we're going to have user 3 with an IAM inline policy, okay? And that user 3 can have access to Amazon EC2, view, start, and stop the access, right? Now, we're going to see that in EC2 support group, EC2 can have Amazon EC2 read-only access. And in S3 support group, we're going to have a user 1 that has an IAM policy to read only in S3. Okay, so that's going to be the final product of your lab. Okay, so guys, let's go to Canvas. Let's go to Canvas, right? Let me know when you're in Canvas already. Okay. So for the new students, the ones that were added recently, I believe you have access to that too, right? You should have gotten, in the case of Ruben Balmaceda, Diana, Dania, and Maria Roscoe, and Taner Mo, you should have gotten an email from me today where you have access to Vocarian. Okay, and then you can access that account. Or guys, I believe you got access to Canvas, right?
They didn't tell you actual ID. They just said all the access. So the access.
So if you have access to Canvas, you can
come. All the access. Okay, there's all the access.
Okay. If you have access to Canvas, then you can come here.
If your boss asked you, give me all the answers. He didn't say only the ID.
Hello. Hello. Okay, so we have here the Canvas part. We can click here on modules, right? And then you go to module 4, right? In module 4, you're gonna see lab 1 right here, okay? When you have lab 1, then you can click on lab 1, and then you're gonna be taken to that particular place where you can see the first lab that is already published for you. Okay, so I'm gonna put you in teams just in case someone needs help, right? Working in the lab. And you can support each other in that. Edward Diaz, you should have access because I sent that email. Davin, you should have access to that too. We make sure that everybody has access to Canvas. Okay. If I look for your name here, I see that Edward, you're here. You accepted that. And David, David, you should be somewhere here.
Actually, that was for the Cloud Guru. That's why I said that, but I'm already in.
Okay. Sorry. Okay, so I'm gonna get that done as soon as possible. Okay, so guys, I'm gonna separate you into teams, right? And you can support each other, just in case someone needs help. I'm gonna just create 5 groups of 5 or 6, and then I'm going to break out the rooms right now. Okay. Hey, Christy, can you join?
Hello? Is class over?
Almost over.
Okay.
Guys, I just brought you back to the main class so we can be dismissed, but you don't have to close your lab. You can still work in your lab and finish it because you don't want to start all over again without finishing. Could you finish it or just still working on?
I finished.
I got to finish as well.
Okay, good. So what do you think about the lab? Was it useful?
Yes.
Yeah.
It makes more sense to do the things and to listen about them.
Facts.
Right. Yeah, I wish this class was in person because in person I get to do a lot of things. Yeah, a lot of practical exercises and challenges and things like that. But it's only 3 hours is online. You know, that makes it a little bit more difficult, and we have more restrictions. Not restriction, limitations. And but it's good. It's good. The other labs are going to be more interactive. They're going to be more hands-on, more practical, and then you're going to enjoy them more. Okay. So guys, don't forget to do the knowledge check. Okay, for module 4. Okay, the video is going to be available as soon as we're done. I'm going to post the link on Slack, and then you're going to be able to access that video. Okay, so I wish you the best. Continue studying. Okay, remember next week we're going to schedule the exam, probably by the end of the week, and we start with exams next week. Okay, practice exams, because it's the already the 3rd week next week. Okay, so 2 more weeks and we're done. Okay, so I wish you a good night, and I'll see you on Friday. Okay.
Good night, Professor.
Do you have
Good
any
night.
questions? Do you have any questions before we go? No questions?
No.
Okay. So good night. See you on Friday.
Good night.
See you. Good night.